So that gives you the multi-threading that's in there now. Hash lookup of the call numbers, so that inefficiency is being worked around pretty well, I think. And also there's an enhancement in the protocol which allows you to transfer the media off your intermediate asterisk box and route directly to between your endpoints where the network allows it. Those things together should give you, and I saw a thing on the asterisk users mailing list, somebody had done a comparison between SIP and EAX in 1.6, and in some cases EAX is faster and in some cases SIP is faster. Generally SIP is still slightly faster, but we're not, the difference isn't that big, so let's say comparable for the moment. And I think there are some enhancements that we could, can still be made to level that playing field even more. So that's the performance. Then the other really, really cool thing is Mark put encryption into EAX. We've documented it in the RFC, and I've actually implemented it on a separate client, which is really nice. But the great thing is to use it on any modern asterisk. It's one line in iax.conf, and all the calls between those two asterisks will be encrypted. You don't have to do any key management because the key is derived from the password, which gives you the means that your password needs to be reasonably strong, or rather your encryption is as strong as your password plus your random number generator. But it's a decent form of encryption. It's really easy to install, and you should all just turn it on, and it will magically happen. And it won't make any difference to the rest of your configuration. Just that all of your audio between the boxes that you switch it on will be encrypted. The other nice thing is there's a load of people out there who've implemented EAX in open source platforms. So obviously Asterisk, and then derived from that with a way back, there's the EAX client, and there's a whole lot of platforms that use that, of clients that use that. FreeSwitch has derived their EAX interface from the EAX client, but Yay have gone off and implemented a whole new set in C++, as far as I can see. And then there's some Spaniards who, in a slightly academic way, went and implemented EAX in Java, and there's a full Java library in Google Code for running EAX. And to be honest with the RFC, if you've got a couple of weeks and you know what you're doing with networking, you can implement EAX yourself. So it's a huge step forward. Then the other thing that a lot of people don't notice is it's got built-in link quality monitoring. So two asterisks that are talking to each other will constantly monitor that link and give you statistics that you can extract from your asterisk in a running call for the things like the jitter and the round trip time and packets lost and stuff like that. It's really easy to obtain straight from the asterisk just by doing a iax2 show net stats from the CLI. And that's a much undervalued feature. I think it's great, and you get a sense of how your link is working without having to kind of fire up Wireshark and a big analysis tool or whatever. So that's a huge, huge thing for me. So all those enhancements still leave you the question, well, why would you bother? Why don't you just use SIP everywhere? And the answer is you can't. There's a lot of places where SIP doesn't reach, just doesn't work. You can't get it to run in certain natted environments, and there's a whole lot of configure you need to do in the firewalls or install a VPN. So if you're in a hotel, for example, or a conference, and you can't get at the firewall, you don't choose to install a VPN, so it's a kind of casual use, then with EAX you don't need to. You plug it in and it's probably going to work. Now, it's important that we keep track of this stuff, because if we don't, somebody else will. And the people who will be Flash, and the back end will be proprietary. So it's really crucial that we address this